Hi, Sarah. Thank you so much for your patience. I've gotten a lot of requests to go over these, and I'm certainly happy to do it. It's just managing doing it is another story. So I'm happy to go over your test with you. Let me see what you got here. So for part 1, okay, I can see that this confused me a little bit. So first of all, I'm so glad you did this, right? This is positive infinity, and positive infinity is a way better answer than DNE. So you don't need to write both of these. This is perfect, and I like that you recognize that that was positive infinity. Now, on this next one, the way you wrote this got me confused. The answer is DNE, and I let you have it because I'm like, okay, well, she got I'm trying to even remember what the picture looks like. I don't have it in front of me. The answer to this one is DNE, and I'm not sure why you wrote 1 here after you got DNE and DNE. So I mean, that I sort of figured you had that, but I hope my logic was right on that, because it doesn't make sense that if you have DNE and DNE, that would equal to 1. That wouldn't. So, okay, so the answer to this one's DNE, just to be clear. As you can see, I can rattle on and on something. Let me just go ahead and move on to the next thing. All right, for letter B, this is a step function. You wanted to put something in a little smaller than 1. That's a special case. So you wanted to put in something, sorry, not smaller than 1, smaller than 2. So something like 1.9. And then as you know from lecture, this rounds down. So negative 3.1 would round down to negative 4. It doesn't, if you say negative 3, you actually round it up. There's no H in this. I'm not quite sure what you're doing there. We're not doing this by the limit process. This is a sort of plug and chug, but it's a special case, so you always want to stay off center, because since they're stairs, you have to get on the correct stair, and the only way to be sure you do that is to be slightly off center. Because if you're on center, if you're right in the middle of a step above you and a step below you, you're going to have 2 different answers. Oh, okay. Did you draw it here? Okay, this would mean it shifted 5 to the right. So this, if you draw this, the first step is actually over here at 5. And then it goes up and up and up. But this is the right idea. So when you're on an integer, you're in between steps. The right side's open, by the way, on these lines. You're in between steps. So when I came in from the left, you were actually on a lower step versus a higher step. So you put me on a higher step. And what I notice with students is sometimes the first test doesn't go well, but all the other ones are excellent. It's just limits are hard to give partial credit on. So you sort of either have this one or you don't. And yeah, so I just sort of noticed sometimes the student's grade will go up a lot after this test because, you know, they can show work and show that they know it. Whereas this is just, you just either have it or you don't. All right, let me see what else you have. I'm just sort of going through the notes here. Okay, letter F. Let me see. Oh, this is in order. Okay. I had a couple students do this. You're using L'Hopital's rule, and I didn't teach that. This question, I wanted you to use the special trig limits. I'd asked you guys during lecture to use the special trig limits to know them for the test, and that's this problem here. So I gave you half credit because you technically did it right, but part of this class is learning the techniques and tools that I'm teaching you, and you didn't use the special trig limits, which is what I was testing you guys on. So let me just show you here. I think I wrote it out. This is actually Calc 2, what you did, and I didn't teach that anywhere. I always, yeah, that's just, that always surprises me when I see something like that. Let me just find this for you. You may already know now how I was asking you to do this. All right, so here I multiplied up, down by x over x, and then you guys memorize this one to be 0, this one to be 1. Some people multiply it by 1 over x to both sides because they see it better this way. This one's 0 and this one's 1, so it's 0. So just sort of however you see it. I will put these trig limits on the final, so they're going to show up again. So please, for indeterminate form on trig, in this class, use the trig limits and not the L'Hopital's rule, which is Calc 2. If for some instance in the future you're just not sure and you're using a technique I didn't teach, can you just ask me? I did have a student ask me during the exam, can I use L'Hopital's rule? And I said, no, use the special trig limit. So if you're just sort of unsure and you're going to use a technique that is not in this class, like just check in with me, because I may say yes, I may say no, just so we're on the same page next time, if you seem to know Calc 2. Okay, let me see what else here. All right, this one, letter G, this guy's bottom heavy, right? Because the output of a sine function only oscillates between -1 and 1. So this is bottom heavy because you have basically 1 over an x cubed. So the denominator is going to get very large, and 1 divided by something very large goes to 0. Right? When you go to infinity, we use those top heavy, bottom heavy rules. This one's bottom heavy. So it's going to go to 0. Let me see what else. All right, for this one, you had to multiply by the conjugate. Let me find that for you. You had to multiply by the conjugate of this, right? So the conjugate of this guy is this, and then simplify it all out, combine like terms in the numerator. Then you're going to reduce, and then you try to plug in at the end again, and you get 1/6. Just to be clear, this one's indeterminate form, right? Because when you plug in 4 in the beginning, it gets 0 over 0, and that's a technique you use for radicals. We rationalize to the other side. We move the radical to the other side. Okay, let me see what else I'm accidentally hitting this button here. I just went over okay. All right, then we just have, you did great, 3, 4, 5, excellent, really nice. Let's look at number 6. Let me see what happened on those. Oh, maybe we were there already. We were. I was magically there, and all right. This is the step function. So this process, you're just looking at the step at the origin, and this has steps at every integer. And so this technique really is not appropriate for doing continuity. Not that you never use limits in continuity, you at times do, but remember, this is discontinuous at 0, at 1, at 2, at 3, at 4, at 5, like everywhere. It has an infinite amount. So what you wanted to say for this is that it's discontinuous at every integer because of the gaps, and that's non-removable. You had a picture of the step function at the very beginning, so I know you know what that looks like. So this one you want to say, and just if you're very visual, which most of us are, I'll just let you look at what I specifically wrote. Let me just get my notes out for you. Oh, okay. I didn't do much more than just say discontinuous at every integer, non-removable, because you have an infinite amount of gaps, right? You have a step. These are a bunch of steps. I just wonder if you need me to point that. I think you know what this is. I don't think you need me to do this, but I just, it's one of these, right? That's one of these where this is not a continuous function. That's a discontinuity. That's a discontinuity. Right? There's an infinite amount of these forever at every integer. That's what letter C is. Okay. Okay. Let me just see then. Letter D. Letter D. Okay, remember when you get 0 over 0, that's indeterminate, not undefined. So indeterminate actually graphically makes a whole. So at -3, that's actually a removable, okay? A removable discontinuity. So this comment was correct here. It was not categorized correctly. So the only thing that classifies as removable is a whole. Non-removable is a VA or a gap. All right, so this was just a classification at the end. I want you guys to be able to classify removable or non-removable. At the very least, I did give students credit if they said, oh, that's a whole. They knew what that was. All right, overall, your test was excellent. Again, with the limits, and I do see this, is that, a student will score, not as high as they would like on the first test because there's not a lot of partial credit on these on the limit exam, but then later on they score really well because there's a lot of steps and students can get most of the credit, if not all. All right, Sarah, I hope that helped. I will catch you down the road. Bye-bye.